So how many of you are first-time OraPub webinar attendees? Go ahead and type that in. Give me a Y, give me a yes if this is your first time you've been to one of my webinars. Gabrielle, wow, fantastic. John, all right. A couple of you, oh, wow. How did you guys hear about the webinar? It's been a while, OraPub version Peter, oh, that's great. Oh, hey, when you do the, when you guys do the chat, can you send it to everybody? Okay, because you are being recorded, so they can, well, they might not be able to see it, but people on the recording will actually see it. Yeah, my friend told me. Oh, fantastic. Okay, yeah, I have a pretty active and not aggressive, what's the right word? Very enthusiastic OraPub member contingent in Brazil, and that's why my last video seminar that I did, I did a video about this guy riding a street bike through the streets of Brazil, and it was it was pretty fun. They got a big kick out of that. All right, so where's everybody located? I know we have some people in Brazil, obviously. So type in where are you from? Country, city, state. Belgium, fantastic, Peter. Oh, all right. All right, so it's the end of your day here. So we got Belgium, Montana, it's its own country, Green Bay, London, Iowa, San Francisco, Cincinnati, Nebraska, Newtown, Pennsylvania, Maryland, New York City. Welcome, New York City. I don't get to me from New York City. That's great. Denver, Irvine, California. Hey, I lived in Orange until I moved up to Oregon. And we got some Houston and Belgium. Oh, fantastic. We got people from all over. Do we have anybody from like the Middle East, Asia Pacific, something like that? India. There we go, Narayana. Welcome, Narayana. It's good to see you back. Kuwait, fantastic. We have some OraPub members in Saudi Arabia, and more recently they've joined too. So something's going on. Their word's getting around. So that's really, really good. So any of you not OraPub members, I recognize a few of you, but I got a feeling that most of you are not, because I've given this the bulk of this presentation before. Anybody OraPub members that are online? I am not, Sam. Well, you know, Sam, we can fix that. Not a member, no, but how many of you are members, though? Yes, okay, we got Jimmy. Oh, that's right, we got Jimmy here. Kim, you're a member, right? Yeah, you're a member. Yeah. No. So we just have a few. Yeah, that's not surprising. In fact, if you'll notice here, I keep saying we're going to start in 15 minutes, and nobody's even chatting anything. They're like, oh, Craig, we've heard this before, you know, kind of thing. So, okay, so we're going to go ahead and get started. I'm going to shut off the chat here, or I'm going to move it out of the way. Hopefully that doesn't start going off. I was told that I confused some people with the passwords and everything, because I had on the website, I had a different password than I did on the email. So it's a typical Craig thing. So I changed that, and we should be good right now. So, okay, so let's get into it. Okay, we have a really super packed, there's a lot in this one. I really try hard to make it so it's not so big, but you know, that's just the way it's going to be for a little bit. For this presentation. So let's go ahead and get it. Oh, so obviously we're going to talk about how to develop solutions, right? When the top event, which is really not event, is DBCPU, all right? And this is really, when you get to this wait event, not only is that, when you get to DBCPU, if that's at the top in terms of time, you know, the solutions and what to do it varies hugely on what's going on at the operating system, and then what the actual top wait event is. And that really drives a lot of your solutions. So I picked this situation. We have a real life production Oracle AWI report that I'm going to use for this webinar. So, oh yeah, and hey, if you have any questions along the way, put them in the chat window. Okay, if I miss it, I will go back. And for those of you that have been in my webinars, you know that when we're officially done, I will stay online as long as you guys have questions. Okay, so I'll be here probably much longer than you're willing to stay on here. So don't worry about me not answering your questions. Okay. All right, so here's the situation. So overall, performance just sucks, right? I mean, as far as the users are concerned, you got a big pervasive problems. And so there's been months of meetings, right? And management finally wants you to get involved. For whatever reason, they say, okay, now's the time. You guys need to do something. It's your database, right? Typical stuff. So in this kind of situation, really, you do the right thing. It's very pervasive. Overall performance, it's repeatable. Everybody knows about it. You know, it's not a surprise. You run an AWI report, and you pick one of the most intense, that's key, one of the most intense hours, and you notice the top event, but in terms of time, the biggest chunk of time is the DB CPU. And just in case I forget about this, DB CPU is the CPU consumption for the Oracle foreground processes. So if you look at the AWI report and it's an hour long, then that's going to be the sum of all the foreground process CPU consumption over the hour of that AWI report. Okay. Now, what really freaks people out then is the top weight event is cursor pin S weight on X. And that's why we have a lot of content to go over in this webinar, more than usual. Usually I don't have as many slides I'm going to go over, but that's because I need to get into the library cache and the shared pool a little bit as we deal with this weight event. So this cursor, anytime you see cursor, think library cache, which is in the shared pool, and we're dealing with cursor management, okay, which is dealing with like parsing, right, getting SQL statements into the cache and then managing those, okay, and we'll get into child cursors too. So this is where we really begin. This is the situation. So we're going to do a time-based analysis. I'm going to show you real quickly how to do that. Hopefully you guys have either heard me or read some more about that before, and that won't be totally new. If you have, it'll be a really, really good review. Okay, so I'm going to do that, and this is going to be really quick though. I won't spend a lot of time on this, but we're going to integrate what's going with the operating system with the Oracle time-based analysis, and that's going to lead us, right? It's going to lead us to those top and the important SQL statements. Okay, and then of course because of the weight event situation, that's going to lead us right into the library cache, which means we got to talk about memory access, right? Serialization control. And then some interesting ways to improve SQL statement performance. Although this is going to be less, though, in this particular presentation. So hope you guys liked the last, guys that remember, we did, members of the last presentation, so I had a guest speaker from SolarWinds, Janice, and she talked about execution plan stability. Huge, huge amounts of content. So I said, Janice, you have to come back and split that in multiple pieces and do some demos and stuff for us. So, and I also have working on somebody who's going to do some webinars on networking for us too. So, which is going to be really cool. So this is where we start. This is the AWI report, and you can see a DB CPU is at the top right here. Okay, and followed by the cursor pin S weight on X. Now, this is important here. So I made a note here. The background process weight events are not shown. Okay, this is correct. When it does say foreground weight events, that's all that are there. And so we will need to go look at the background process events also to see if their time is significant. Okay, all right. So since many of you have never met me or been to a webinar, I'm going to give you a real quick intro about myself. So my name is Craig Shallahamer. I live in the U.S. in the Pacific Northwest in the state of Oregon. Lived here for about 3 years now. Grew up in California, Southern California. There's a difference. I'm a long-time Oracle DBA, and I specialize in Oracle database performance and predictive analysis. And those of you that are members, you've noticed now I started doing some more predictive type seminars. Got a couple or webinars coming up. I do a lot of performance research, and I'll put that on my blog. Those of you that follow my blog, you're probably wondering, Craig, why have you not been blogging this entire past month? It's because I've been doing some live video classrooms, and we just announced, before I forget, I'm so stoked about this, get this. Kim, you were on the beta class on this, but if you go to training here, you'll notice we have live virtual classes. And we have the first one now, it's called Oracle Tuning FastPath. That's for like brand new Oracle DBAs, or you're not even an Oracle DBA. And you can register now. I actually have classes open for that. And how we do that, they're going to be 2-hour sessions, and there's 4 of them. It's like a Tuesday, Thursday, Tuesday, Thursday. And I have them at 2 different time zones. So we should be able to cover the entire world with those. So next week, I'm going to put another class online as well. So I'm not sure what that's going to be yet, though. So that's why I don't want to say too much about it. Anyway, so that's why I have not been blogging. Author of a couple books. These are the new covers for the books. Content is the same, in case you already have those. Do a lot of conference speaking, teaching, mentoring, and I'm an Oracle ACE director. So that's how I hope to get to Brazil, is through the ACE program. So hey, if you guys ever want to contact me, you can email me anytime. Okay. Go ahead and do that. OraPub members get priority, but you can go ahead and email me. And if you remember, we got our Slack, right? A little Slack application here. That gets pretty chatty sometime, which is a lot of fun, actually. And Twitter, OraPub is on Facebook also, believe it or not. We're there. And connect with me on LinkedIn if you haven't done that before. Okay. All right. So OraPub, we're all about Oracle performance. I work with DBAs. My personal goal is to help DBAs get ready to solve just the biggest, nastiest Oracle performance problems. And so that's why I have a bunch of free tools under resources. All my presentations at conferences are available for free off my website, as well as a bunch of tools. And my really primo material, that's for members only, like video seminars, these kind of webinars. I do a couple of these every month. In fact, I'm going to do, those of you that are members, next week I'm going to do one, and that's going to be the part 3 of parsing. I think that's what that's going to be about. So, okay, so it's about 15 after, so man, we got to get going. Learning Path, those of you that are members, this webinar is the closest one is about tuning Oracle using an AWI report, as well as the Oracle Memory Serialization Control. Okay, because since we're going to be talking about mutex. If you guys see me do any scripts, right, other than just like paste and SQL in, today those are going to come from my OSM toolkit, and you can get that off my website, totally for free. Do whatever you want with the scripts. Okay. All right, knowledge transfer. You guys like that? Huh? Oh, hey, I missed you, Kim. There, fast path training was great. Thank you. Yeah, I'm hoping that turns into a really good class. So, okay, so the question here is, you see a little goatee right there? That's because that's me. So I'm Spock. Hopefully your eyes do not look like that. I'm hoping that, I don't know if I want to stay on that picture. Okay, so let's get going. Any questions so far? All right. Everybody good? Good. Type in, yeah, man, I'm good. All right, so I got some questions for you. Yes, oh, fantastic. Okay, so I got a question for you guys. Let's see. Okay, quick review, right? What is DB CPU? What is that? We got to make sure we understand what DB CPU is. Okay. Here we go. We have, come on now. Here we go. Got a couple questions. What is DB CPU? I just said that, right? I said at the beginning, this is why I'm doing these questions. All right. And by the way, don't worry, you will not be judged, okay, if you put a wrong answer or a similar or a closely right answer. Don't worry about it, okay? Yeah, Jimmy, there you go. Fantastic. Foreground processes. Vaclav, exactly. It's CPU consumption. Kim, you must have typed that in and then pasted it in there. Yes, okay, it is foreground, so I'll put FG, foreground process, CPU consumption, okay? And Oracle gets that from the operating system. Actually, there's a call, in C to the OS. It says, how much CPU have I consumed so far? And it does this fairly frequently, and it actually varies how often it asks. But it can ask, at the worst case, like every 3 seconds. But if it's really burning CPU, it'll spin almost and get how much CPU it's actually consumed. Excellent. Okay, excellent. Next question here. Okay, what are the two I'll say, this is a weird question, 2 components, I don't know, or types of time related to Oracle processes? Okay, there we go, Jimmy. Okay, exactly. Okay, so the first one, right, is the CPU consumption. Right, and if it's a foreground process, that is the DB CPU. Okay, so we have CPU, and then we have the wait time. And for us, it's really going to be the non-idle wait time is what we primarily care about. Excellent. Okay, good. Okay, so now this is a key question here. Okay, I'm going to say, so if an Oracle process, okay, if Oracle, just say like a foreground process, processes, okay, more work, would we expect to see more or less time? Okay, so if an Oracle processes more work, like it than it has in the past or something like that, or if it keeps continuing to process work, would we expect to see more time? That's our CPU in the wait time, or less time? What do you think? Yeah, we have some more. We have more. Yes, more wait. Yeah, for sure. If we're doing more work, okay, we're gonna have more CPU, and hopefully not too much, but possibly we're gonna get some more wait time as well. Okay, great, great. Because in order to process work, right, however you define that in Oracle, if you're actually doing work, okay, there's got to be some CPU time. There's got to be. That's just the way Oracle works, right? You got to have CPU to process it. Okay, and you could have you could have some wait time as well. Excellent, excellent. Okay, all right. So now we're going to jump into the slides here real quick before we get to the AWI report. Okay. So now we don't have to look at that anymore right there. Oh, let's get my face out of here for a little bit. Okay, all right. So I don't think we have anybody using the Slack app here, do we? Oh, no, I don't see that. That's okay. As long as we're chatting away here, we're good. All right, so what I'm showing you here, this is an example of just one single, let's say, foreground process, and it's serial. Okay, so we're going left to right. Okay, and it's what the C is for burning CPU, the W is for waiting. Okay, so the process starts, it burns like 5 units, whatever that is, 5 units of CPU, and then it waits for a couple units, burns more CPU, waits even longer, and then burns some more CPU, and it's done. Boom. So let's say just the SQL statement is actually done right here. Okay, so we have the total time, if you add up all the CPU and the wait time, is 11, and that's the elapsed time. So if you go to your AWI report and you go way down here to the SQL statements and you see things like elapsed time down here, guys see that way down here? If you can see that elapsed time, that's what we're talking about right here. Okay, although in this AWI report, this is the total elapsed time. So that would be for like a particular SQL statement over the snapshot interval, that elapsed time would be all of its CPU and all of its wait time. Okay, now this is not the wall time. Okay. This is actually the elapsed time, and it should be really close to the database time related to this SQL statement as well. Okay, so notice now we're burning there's some time related here, so there's going to be some kind of work, and I've decided I choose logical IOs or buffer gets to be my unit of work in this particular case. Okay, all right. Hey, one little thing that really helps me understand what's going on within Oracle is that the wait time. Let me talk about the wait time for a second. Oracle wants to burn CPU, right? Processes want to burn CPU because that's how they really get the work done. But sometimes they have to stop burning CPU. It could be because of lock. It could be because the process is trying to acquire a latch and it has to back off and wait for a little bit. It could have been an IO call to the IO subsystem, and therefore it can't burn CPU. In that case. And so the wait time, in a sense, it's the process waiting before it can then burn CPU again. Because it's all about CPU consumption, right? So the wait events, the actual wait events themselves, they give us clues, right? They give us clues about why the process is unable to burn CPU. So, and this is really important to understand because we all encounter wait events that we don't know what they are. Right? And if you're not sure, just ask yourself, okay, what is this? This wait event is giving me clues about why the Oracle process had to stop burning CPU. And once it gets received or the wait is done, it can then continue to burn CPU. So keep that in mind. Oracle processes always want to burn CPU. Okay. All right. Let's see what the next slide is. Okay. Let's talk about serialization control here. Okay. Any questions so far? You guys all right? Any questions? Because we're going to switch topics here, but you got any questions, go ahead and type those in. All right. Gabrielle's ready to go. Good. Vince is good. Excellent. Okay. So, let's talk about serialization control. Let me get, this is like my token right here. Okay. So it works like this. When we're dealing with Oracle memory structures, okay, and think about linked list. Don't think about like buffers in the buffer cache, okay? Think about like cursors in the library cache, just like chunks of memory, okay? Or in the buffer cache related to that, we have the LRUs and the cache buffer chains in the write list, okay? Those are all like chunks of memory. Think of little nodes of memory, linked list. When any time a process needs to access those linked lists or they need to make a change, they have to get permission. See, Oracle thrives on the illusion that there's simultaneous access, that we can just do anything to anything in Oracle, including memory, at the same time. Okay, it's an illusion. It's not real. So Oracle has to control access, and it has to be super, super detailed controlled access. So what it does, if a process needs to, let's say, look at a piece of memory, like let's say it needs to scan some chain or something like that in Oracle's memory, then it will figure out, the foreground process will figure out what token, okay, it needs to acquire before it can then access that memory structure, okay? And that process, it kind of goes like this, right? The foreground process will repeatedly ask, say, give me the latch, like give me the token, give me the token. And it will keep doing that until it actually gets it. But if it can't get it after 2,000 attempts, it will back off, okay? It will back off. So that beginning part, when it's saying, hey, give me that latch, give me the latch, okay, that's called spinning. Okay, so a question for you guys here, okay, is the spinning, okay, is the foreground process spinning to acquire a latch? Is it CPU consumption or wait time? Or both? What do you think? Oh, I got some pretty quick responses to this. Great, great. Okay, CPU. It's CPU. Think about it, because if you keep repeatedly doing something, like there's movement, you can see me moving right here as best I can in a webcam, but I am burning CPU when I do that. And if I can't get the latch by burning the CPU, then I'm going to back off, and that's the wait. That's the wait. So, and the same thing happens with mutexes, which is just another way that Oracle can control the serialization. It's just like latches, just another way to do that. So when we look at the top wait events here, you scroll up here at this is the AWI report we're going to use here, right? When we spin, we're burning CPU. But when we can't get this particular mutex and we back off, that's the wait time. That's the cursor pin S. So now we have to ask ourselves, well, why can't we burn CPU? The description and what this wait event means gives me the answers to that. Okay? All right, excellent, excellent. And so then you know the wait time, the sleep time, to back off from trying to acquire the latch or the mutex, that is the wait time. And here's an example of a wait event right here. Okay? All right. So you guys all set? You good? I think we're all set to start doing our little analysis here, our time-based analysis. Okay. I'm going to put the chat up here because there's nobody actually on Slack right now. So which is totally good. That's okay. All right. Good, good, good. All right. So what we're going to do, in fact, I'm going to make my picture a little smaller here. I'm kind of distracting myself here. I want you guys, but it kind of helps you guys keep track. I think that's what we want to go to next, right? Oh, yeah. Oh, there's the, okay, I'm going to skip that. Okay, so this is where we're at. This is where we're actually going to start right now. And then we'll get into the library cache stuff in just a little bit here. Okay, so we're going to do an Oracle time-based analysis, okay? So we're going to start. This is the Oracle side of things, okay? Now, every DBA needs to be able to do this like in their sleep, okay? I'm not joking, man. You really need to get good at this. So we have, at a high level, okay, we're going to have CPU time, and there's foreground process CPU, and there's background process CPU. Okay, so I'm going to go through this pretty quick, all right, because we're going to run out of time here. Or it's either CPU or wait time. It's one or the other. This is why I stress this at the beginning. An Oracle process can either burn CPU or can wait to burn CPU. So it's either CPU or waiting. And if we're waiting, I'm going to break up all the possible wait events into two main categories, either I/O or something else. Okay, now this is for simplicity, and it also helps us to communicate what the heck is going on to others. Okay, now it also is helpful when we break down I/O to one more level into read and to writes. Okay, so then what we're going to do is that we're going to take this AWI report here, and we're going to slot those top few events in here. And Kim, you were in the fast path course. So I think I might have used the same AWI report. I did to do that because it's cleansed, right? It's cleansed. All right. So DB CPU. Ask you guys question here. Is that? I mean, you know it's CPU, right? I'm not going to ask you that. Is it foreground or background process CPU? All right, we have a foreground process. Yeah, it looks familiar, Kim. That's because it probably is familiar. Okay, that is foreground. And the time there, over the snapshot interval of this report, is 2195. I'm going to round up. Okay, what's the background process time? It's not there, right? It's not there. So we have to go get it. So we're going to get that from the time model, the system time model. And usually that's way near the top of the report. And this comes from the view $v$ systime model. Okay, this is started in 10G, fantastic. It's an awesome view. So there's the DB time, or the DB CPU. That's where that came from right here, the foreground process. Way down here at the bottom, that's where the background CPU time is, and it's about 68 seconds. Okay, usually it's way, way, way smaller. Okay, and sometimes I see now the developers finally started to put the total CPU here, and which I believe is correct, 2262. Okay, 2262. Whoops, 2. Got to type that in. Okay, so that's our total. Let me put this in here like that. Okay, so that's the total CPU consumption. So all the foreground and background processes over the life of this, or not over the life, over the snapshot interval, which is 60 minutes right here. Okay, by the way, see it says elapsed? That is not elapsed time. That is idiotic that Oracle called it elapsed because it really confuses DBAs. That should be the snapshot interval time, not the elapsed time. Elapsed time means something else to us. Ticks me off when they do that stuff. Okay, let's get back up to our wait events. Remember, these are just foreground, so we're going to have to check the background. Okay, so what's our top wait event? What's our top foreground wait event? No trick here. Let's check and see if you guys are awake. I'm glad I asked it. Okay, yeah, it is the cursor pin S. Okay, DB CPU is not a wait event, right? It's CPU consumption. Fooled you on that one, didn't I? Okay, so it's cursor pin S. Wait on X. So where is that going to go? Is that going to be under CPU or wait? One or the other, right? It's wait. Okay, now is it related to I/O or is it to other? Himmel, you actually know what I'm going to ask. That's no fair, man. Yeah, it's pretty logical what's coming next, right? It's other. Got to have some fun doing this stuff, right? And that is 234. 234. Okay, so now the question, since you might say, well, Craig, could that be related to I/O? Okay, here's how I look at this. I say, well, is this wait event preventing the process from burning CPU because it's waiting for I/O from a disk? Is it like reading I/O? Is this wait event telling me I'm waiting for I/O from a read, or am I trying to do a write and I'm waiting for that to complete? No, you say, well, no, that doesn't make any sense. This is dealing with memory structures and the library cache. Yeah, so it's not I/O, it's other. Okay, so that's how I kind of ask myself that. Okay, all right. Yeah, in a sense, it's waiting for CPU. Exactly. Yeah. Excellent. Okay, now the next one is direct path read. Okay, so where would direct path read go? First of all, we ask ourselves, is it CPU or wait? Okay, we know it's not CPU because there's only two CPU, numbers. There's DB CPU, which is our foreground right here, right? DB CPU, and this is obviously the background, right? So we know it's going to be an I/O. And it's pretty straightforward because it says read, right? So that kind of gives that away. Okay, so if I was to put this here, okay, I put like direct path read, and then I put my time down here of 42 seconds. Okay, now this is important. Okay, this drives people nuts when they're learning how to do this kind of stuff, when they do an Oracle time-based analysis. Okay, the question is, where do you stop? I mean, how far down do we actually go here? I mean, when is it not significant? Okay, it's a valid question. It's very relevant, and it leads to all sorts of conflict in DBH group. Okay, here's how I actually look at this. Okay, I ask myself, if I eliminate this 42 seconds here, will that significantly change the profile, the time profile right here? So what do you think? If I got rid of the 42 seconds, if I said, you know what, this is insignificant, it doesn't change the overall profile, then I could just get rid of it. So what do you think? Should I get rid of that? What do you think? Yeah, it's not our problem. Exactly. It's a stinking IO subsystem. Yeah. No, it will not fundamentally change the profile. Okay, and the reason is because if you look at where the time is, that is the big chunk of time right here. We're not even close to that in the wait events. Okay, I mean really, cursor pin S is insignificant from a time perspective, but it is the top wait event, so it gives us clues about what Oracle's doing with the CPU consumption. Okay, but as we'll find out, it's not that big of a clue. Okay? So I would just stop and not even put direct path read. Okay, I just wouldn't do it. Now, if there's a lot of conflict in the DBA group about that, then just put it in, because it's not going to make any difference in terms of the solutions that you're going to come up with. Okay, so ask yourself, if I don't include the wait event, will it significantly change the time profile? Like what we're looking at here, we're looking at like an ocean, which is full of little fish, right? There's a current to the ocean. And if we get rid of the direct path read in our analysis, will that shift the current of the ocean? Okay? Absolutely not. It won't. So then just don't put it in there, because it just forces you to do more math and it can complicate things. Okay? Now, you guys okay with that? Oh, do we consider the number of waits? Great question. No, I don't consider that. No, because it's time. And because, see, users care about the time. Now, in a sense, they care about the waits, but that's because the number of waits turns into time. Okay, so when we do our time-based analysis, the reason we're actually doing a time-based analysis is because users feel performance, right? They feel performance by experiencing time, like a lot of time, too much time. And so if we set up our analysis based on time and we figure out ways to reduce the time, the hope here is that the users will have a better experience because things won't take as much time. Okay, so really it's time that counts. Now, the number of waits is important because it gives us ideas about the average wait time. Okay, and that actually it can be very important to us, as we'll actually see. Okay, that's a great question. Great. Don't let that distract you. Say, wow, that's a lot, man. Yeah, that is a lot. But look at, they're like crazy fast though. Okay. All right. All right. So we need to check the background wait events. So I'm going to scroll down, and I know this probably make you dizzy on the screen here. It's making me dizzy. There's foreground wait events, right, which we looked at. We're going to go down to the background wait events. In the top background wait events is log file parallel write. So if I was to put log file parallel write here, we know that's not CPU, so it's got to be wait. Okay, because there's only two categories for CPU. So is this an IO or other? What do you think? Ask yourself. If it's IO, I'm either waiting for reads, information to come back for the IO system, or I'm waiting for a write, some data I push to the IO subsystem to be acknowledged that everything's good. Yeah, it's IO and it's write, and it's kind of it's a giveaway here, right? But still, going through that process is really good. Now the question here is, this is 15 seconds. So do I want to put that in my analysis? What do you think? All right, should I put log file parallel write in my analysis? Another way to look at that is, if I don't, will that significantly change the profile? Will that shift the current of the ocean that we're looking at right now? It's too low, right? And we've kind of already gone through this because we already said that we weren't going to put direct path reads in there, and that was 41 seconds. So I'm not going to put 15 seconds of the log file parallel write. If I did, I would put it right here, though. That's where it would actually go. Yeah, too small for the analysis. Good job, Kim. Kim, you learned something from the class, man. I feel so good. I hope a lot of people take that fast path class. But it is a class, though. I mean, it's a legit class. All right, so let's add this up. Okay, so we got 0 writes. Okay, and so our IO is 0. So the total wait then is just going to be 234. Okay, is number. Okay, I should actually kind of do something like that. I want to get this so it lines up right. I don't know. I get too carried away about that stuff. Anyways, all right. So this is the bulk. All right. This is like the mechanical part of an Oracle time-based analysis. This is like, I call this the framework. We're looking at the ocean, the current of Oracle over this snapshot interval right here. So now here's the key thing. Okay, this is super important. Okay, we need to look for the big like chunks or the big piles of time. Okay, we need to find the big chunks of time. Okay, I'm not going to write this because we got to go over this quickly. We got to find the big chunks of time, and then we will develop solutions to go specifically at reducing the big chunks of time. Okay, or okay, although I'm not going to stress this in this seminar, or instead of reducing time, we go for increasing the throughput, like the workload Oracle can process. Okay, but primarily our first goal is to reduce the time. Why? Because users feel time. We want them to have a better experience, don't we? Yeah. Okay, so where is the big chunk of time? Where is that? It's clearly CPU. It's clearly foreground process. Okay, so this is the big. I mean, this isn't, and it's not supposed to be tricky, right? I mean, this is not rocket science, right? Where's the big chunk of time? Okay, so if we want to improve the user experience, we need to figure out a way to reduce the foreground process CPU consumption. Okay, we need to figure out a way to do that. Okay, now most DBAs will say, wow, we got a CPU problem. We got a big CPU problem. And they'll tend to say, well, something's wrong with the operating system. You know, we got all this CPU that we're consuming and all that. Okay, well, maybe not. Okay, another part of our analysis that we need to do, and I'm going to go through this incredibly quick here. Okay, because we need to get into the library cache, right? We got to do that on the operating system. Okay, is we need to take a quick look at the CPU subsystem, IO subsystem, memory, and network. Okay, so we're going to need to do that. I'm going to do this. I'm going to do this over here. Move that around. I want some more. I want this at the top. Here we go. I want to make sure you got a lot so we can actually see the picture. Whoop. There we go. Okay. All right. So let me, okay. So most people would say, hey, yeah, CPU is significant here because it's the big chunk of time, which it is. But let's say the weight of it, let's say the analysis looked like this. And this has got to be careful with this answer. Is CPU important to us now, the CPU consumption? What do you guys think? It's like, you know, usually I don't do trick questions, but this is kind of a trick question. You know, the answer is we do not have enough information. Okay, we don't have enough information because it looks small, like it's not a big deal. But what if Oracle processors want to consume CPU, but there's no CPU available? See, this is like a trick question, right? I mean, this is like another level down. You say, well, that's our big chunk of time. So clearly that would be our number one big chunk of time. And I would definitely drill down on that. And I would have solutions aimed right at reducing that wait time. No doubt about it. But what if there's a CPU bottleneck and Oracle processors want to burn more CPU, but they can't because there's no CPU available? Okay, if that's the case, actually, if this is the case, we tend to get not I/O wait events, but we tend to get the other wait events like cursor pin S, like this. Okay, so in order to answer the question, is this 2262 super important to us, especially when you have a lot of wait time? We need to understand this, in particular, the CPU utilization on the box. Okay, so let's do that. Now, we can derive this ourselves with the data that Oracle collects. All right. Yeah, CPU cannot be ignored. That's a good one. All right. So let's scroll down here. Somewhere Oracle actually is going to put this, and we're going to believe this. We're not going to check it. Okay. I always check it though, but we don't have time to check it now. So, well, if you add those two together, that's about what? 22.2, about 21%. So is that right? Yeah, 21%. 21% utilization. Okay. My rule of thumb is I want that less than 75%. That's just a rule of thumb. Okay. So I'll put like a rule of thumb here. Okay. So what does this mean? Do we have a CPU bottleneck? No, absolutely not. Okay. In fact, this is awesome. Okay. I'm going to give my California awesome. That is fantastic, man. That is so, so good. Okay. So what this means that if Oracle processes wanted to consume CPU even more, they could, which is an interesting question here. So why doesn't Oracle burn more CPU? Okay. So I'm going to say, like, why not more CPU? Let's see. Yeah. So how is this possible? Okay, now this I want to add in here. So how is this possible? Okay. How is this possible? So how can we, you know, we're burning CPU, but there's still we don't have a CPU bottleneck. I mean, how can get us in this kind of situation right here? Okay. And there's two possible things that really come to my mind when I think about this. But think about this. Yeah, okay, excellent. Parman, that is fantastic, man. We could have a serialization issue that is limiting the use of the available CPU power, right? If I have like one process and I have like 10 cores, and somehow the OS cannot split that up, parallelize that, then hey, I'm going to be at 10% utilization, right? There's 10 cores and I'm only able to use one of them. We're at 10% utilization, but you know, it'd be great if I could parallelize and use that up. Okay, so we got a serialization issue on that. That could be a possibility. There's another issue. Anything else? Let's block more work. Yeah. Okay. Yeah, exactly. This cursor, right, which is a mutex, but a latch, that is enforced serialization. So we could have people that are trying to get this particular mutex and can't, therefore they're unable to burn CPU. So you see the story developing here. Okay. Okay, there's something else, and this is one that most DBAs don't want to have to say, but it's actually very, very true. Okay, Oracle is not receiving work, not receiving more work. Okay. So this is a tough one to prove, so what I do in this situation, when I see, as we're going to see, there is no bottleneck on the operating system, which we'll see is the case right here. Okay, yet users are screaming. So think about this: if users are screaming, there's plenty of capacity on the operating system. Okay, and it's not a serialization issue, which it could be in this case. Okay, but if it's not, then that means, hey, it's not Oracle. It's outside of Oracle somewhere. Oracle is not receiving the work. Okay, and I'll tell you the way to get a better understanding and to convince yourself of this is you look at the load profile right here. Look at the load profile. Now, these are, you need to get, on the big databases you care about, you need to get familiar with these. Okay, and if you're not, if you run into a situation like this where people are screaming, okay, and if you demonstrate it's not a serialization issue, and therefore it's got to be Oracle not receiving enough work, what you need to do is you need to find some, in fact, you should probably, in this case, I would use logical reads, okay, and I would graph this. I would get the data from AWR or from OEM or however actually do that, okay, and I would graph that out. And what you want to see is that if there is an issue on Oracle side, you will see the logical read spike when people are complaining. But if they're the same, or that actually kind of goes down, yet people are screaming, that's a clear indication it's not Oracle. Okay? And so you got to put these together, because if you say it's not Oracle, people are going to look at you and just say, come on, of course you're going to say that, right? We've all encountered that. They will laugh at you. So you have to be very convincing to do that. Okay, so let's see, where else we want to look before we, any questions so far? All right, so our price, good. If I had a nickel, I don't know. I can't get that expression. All right, let's keep going to the operating system, and then we're actually going to dive into cursor pin S here. So real quick on the I/O, my trick for it to tell me if there's an I/O issue is I look at the average wait time for DB file sequential reads. Now this is a single block reads. It's synchronous, so there's no funny business. Oracle actually asks, what time is it? Does the I/O, and it waits. When it gets the I/O back, it asks what time it is. It's a single block. So it's very pure, and it's a great way to figure out how the I/O subsystem is doing. Okay, it's not perfect though because it's single block, not multi-block, and it's not a write, but it's an indicator though. Okay, so our average single block read is 0.03 milliseconds. Okay, so single block read is 0.03 milliseconds. Okay, so what do you think? Is that good, bad? Got problems? Ah, Gabrielle, Gabrielle, you must have listened to, or hey, is it Gabriel or Gabrielle? I got to say that right. What do you think? Okay, because I have a daughter named Gabrielle, right? After the angel, right? Gabrielle. Or Gabriel. Yeah, there we go. All right. Yeah, 2 daughters. One was named Gabrielle. A great name. All right. Anyways, so my rule of thumb, yeah, who said 10 milliseconds? Yeah, it's actually excellent. Yeah. Oh, that's my rule of thumb. Yeah, my rule of thumb is less than 10 milliseconds. This is on standard spinning disks. If you have solid state, you want this to be less than 5 milliseconds, maybe even less. I know some people that they want it to round to 0. It needs to be less than 1 millisecond. Okay, it's getting crazy fast. So what is this? So how does this look? Awesome. Looks really good. Really, really good. Wow. Yeah, I mean, that's just crazy. Yeah, disks are getting so fast, you know, until you actually have those. You're like, what? Are you kidding me? Yeah, no, I'm not kidding you, man. They're so fast, man. We're getting to the micro level now. Okay, here we go. I'm looking for memory. There we go, memory statistics. Now, I'm going to trust Oracle here. We need to see how much memory we have available on the box. Now, this can be misleading, so you got to be careful about this. And we're assuming this is correct, which I always check this. This tells us that on the host, on the box, whether it's a virtual machine or whatever, okay, there is 22 gigabytes. In this particular instance, right, the SGA and the PGA, right, is consuming just about 3 gigabytes, right, which is only around 14%. Okay, now, so you might say, well, okay, that sounds pretty good because that's like 14%. Okay, and my rule of thumb here, okay, is I also want that to be less than 75%. If your memory consumption gets up into 75%, bad stuff happens. And it's really easy to detect that too. In fact, I'm going to do a presentation at IOUG on this. And so you guys will, if you're members or not, you'll be able to download that presentation. So it's really easy to tell if there's a bottleneck there. Okay, wow, 10 minutes here. All right, so that looks really good. Okay, however, there's a danger here, right? There could be other SGAs and other PGAs on the box that are not included in here. This is why they actually said the percentage of host memory used for this, they could have added the word for this particular SGA and PGA. So the assumption here is that this is the only instance on the box, and therefore, how does this look? It's awesome. Okay, awesome. So I'm going to tell you that there is no problem. It's awesome. Just trust me on that. I really don't want to get into that because we're definitely running out of time. So how does the operating system look? Awesome. Okay, we do not have an operating system bottleneck, okay, which is kind of bizarre because usually when I'm in this situation here, I'm expecting a CPU bottleneck, okay? Why? Because this is all about memory right here. We're dealing with latches and mutexes because once you get the latch or mutex, then you start burning CPU related to memory management, okay? All right, so let's get back into the slides here real quick. Any questions so far? You guys all right? Okay. Hey, is it okay if we go to like 15 after? If that's going to be a problem for you, would you say, man, just type problem? No. If it's a problem, type problem. Right. Okay. This is being recorded, right? And in fact, I better check here. Is this being recorded? Yes. So you can always rewatch it too, okay? And anybody can watch it. All the recordings for the free public webinars, those are free and public forever. Okay. Okay, great. Let's keep going. We got a really full room, man. I hope you guys are enjoying this and getting a lot out of it. Now it's going to get a little more Oracle internal-ish. Okay, so we need to understand what this cursor pin S is all about, okay? And let me just give you the high level here, okay? What this means here is that as a foreground process, I am unable to burn CPU because I am trying to pin a cursor in shared mode, but I can't, And so I have to wait. Why? Because somebody has it in exclusive mode. Let me get that. Let me shorten that. Okay. I'm a foreground process. I'm burning CPU, but I have to stop burning CPU because I'm trying to pin a cursor in shared mode, but I can't do that because somebody else has it in exclusive mode. So now you got to ask the question, okay, why would I want it in shared mode and why can't I get it in exclusive mode? Okay, well, in order to execute a cursor, right, to execute a SQL statement, I have to pin the cursor in shared mode. You say, why? Because that prevents the cursor from being deallocated. And if I'm executing a hunk of memory, what's in a hunk of memory? I certainly don't want it to be deallocated. So before I actually execute it, I've got to pin it, okay? Which also means, oh, I think I just heard somebody breathe here. Make sure everybody's muted. Yeah, everybody's muted. Sorry about that. I need to make, the cursor is already in existence. Now this is important for understand this. This means the cursor is already there, at least the parent cursor. Okay, and somebody has it in not locked, somebody has it in exclusive mode. So why would you have to have a cursor in exclusive mode? Well, if I'm changing it, like maybe I just executed, I need to increase the execution count. Maybe I've created a child cursor and I've got to, and so I'm changing it and I need to do that, then I'm going to need it in exclusive mode. Okay, so, okay, got a bunch of questions here. It's a holiday in Brazil. All right, man. Okay, 17 hours. Okay, but go ahead. Oh, Peter, I'm sorry, man. Watch the end of it. I'm going to guess the status issue from seeing cursor. Yeah. I guess it could. My guess is it's a stat issue also. Okay, so what this tells us is that this is probably a popular SQL statement that a lot of people want to execute. It could also be a child cursor issue. So let's explain what a cursor and a child cursor is. Okay, so as a foreground process, as a client or a user process like SQL+, I make the request, I make a user call to the foreground process. I say, man, you need to parse this SQL statement. Okay, so the foreground process will look in the shared pool within the library cache and ask the question, does this SQL statement already exist? Okay, and if it does, well, that's good. Okay, but then it needs to go another step below that, and it needs to say, well, is there an appropriate child cursor? Okay, so let's get into a little more detail here. Okay, so what happens here is when I ask the question, is my SQL statement in the shared pool? Is it in the library cache? I will be hashed the text. If you know what the hash value related to a SQL statement, Oracle uses that to hash to one of the buckets. Okay, and then I have to acquire a mutex. Okay, because every bucket has a mutex, or actually is it every cursor? No, I forget, but one of these. Okay, I will then go to this cursor, and the cursor is what is related to the SQL text. The SQL text is part of the cursor as well as the statistics. Okay, and I say, hey, is my SQL statement there? Okay, and if it is, then I will go down to one of the child cursors. Every cursor with application SQL will always have one child cursor. Okay, always one. I will go to this child cursor and I will see, can I actually use this child cursor? But I might not be able to. Why not? There are a number of reasons why not. Okay, and there's 64 reasons defined, and they're defined in $. Okay, $. SQL shared, I think it's cursor or cursors. I think it might be, I'm not sure. And there's reasons, and it lists those, okay? And so if I say, you know what, I can't use that, then I go to this one, I say, can I use you? And if I can't use you, but this is my SQL text, I will then create another child cursor right here, okay? So at this point here, I don't know whether I have to get this in exclusive or shared yet, but once I've got that child cursor actually created, then I just need to make sure the memory's not deallocated, and that's when I'm really going to go for that shared. So it's cursor, thank you. So what I'm expecting here is that is that the SQL statement, the cursor and the child cursor are probably already there. I just want to execute it, and I can't because somebody else is changing it right now. Now, in order to prove that, I'm going to have to go look at some of these tables like $SQL, and I'm going to have to pull here, in specifically AWR, and I'm going to need to see, do I have a lot of child cursors? I'm going to need to do that. And I'm going to see, do I have a high execution count, okay, for these SQL statements? Okay, now this is much easier to do. Oh, all right. Pardon me. So this is much easier to do in Ash because I think I might even have the query here within Ash. Okay, and I'm going to start skipping some stuff here, guys. Let's see. Do I have the query? Yes, I have the query here. Max child number. Okay, this is the query that I would actually run right here. Okay. Okay. I need the SQL ID. Give me a count. And give me the max child number. This is the number of child cursors right here. Okay, there's probably not a lot. What's a lot? You're going to have like 50, maybe 100. Okay, Oracle now, it depends on some underscore parameters, but if you get to 100, it's going to invalidate the cursor and it will re-hard parse again. Now, okay, what's a hard parse? A hard parse is I hash to this bucket, and I look there and I say, hey, are you my SQL statement? And it says, no, I'm a different SQL statement. I'm like, ah, shoot. I'm not in my SQL statement is not anywhere in the library cache then. And I have to actually create the cursor, create the child cursor. That's memory management. There's mutex, all that kind of stuff. Okay, that would be a hard parse then. Takes more time, takes more resources. All right, Kim. Hey, you've heard this. You got to go. See ya. Okay, here's the easiest way to find the SQL statement. In fact, we are going to go look at the application side of things now. Okay. Man, I'm going way too long here. I'm going to work on closing this up here. Hope you guys are doing good. This is good. Application. Okay. All right. So this is what I can do. This is what you do. If you have Ash, just ask Oracle, hey man, when I'm waiting and the wait event is cursor pin S on X, show me the SQL ID. I mean, can it get any easier than that, okay? And if you have an AWI report, and you're going to need to add in some constraints here, okay? So make sure you screenshot this, right, if you want the SQL here, because I'm not going to, email this to everybody. There's a lot of you guys. I can do the same thing, but I'm going to go after DBA hist active session history. Now, you're probably going to filter on database ID and instance ID and stuff like that, but that will give you, that will tell you what the SQL IDs are, okay? All right. So let's say you don't have access to Ash though. Okay. Now, hey, what we're going to do, we're going to find the SQL here. Okay. But before we do that, there's another clue here to tell us if parsing is really an issue. Okay. Because usually when you see this wait event and you see a lot more CPU, it is. But we don't have a CPU bottleneck. So it's like, unless we keep going after the same cursor all the time, then I don't know. So what you do, and this is kind of a cheater's way to do this, I actually look at a ratio, which may surprise a lot of you, but in this case, I actually do. I look at here's the percent non-parse CPU, okay, which is about 97, which means 97%, think of our CPU here, is not related to parsing, which means only 3% of CPU is related to parsing. Man, not much. Okay, now those of you that are here, this is kind of this is like the extra you get for staying here. Okay, because we're dealing with cursors, we're dealing with spinning and waiting, all that kind of stuff. When we start doing a lot of spinning, it's starting to take us a while to acquire the latch permission. Okay, first we start burning CPU. Okay, all right, Peter. Hey, we'll see you, man. Thanks for joining us. So first, I'm going to start burning CPU. Okay, but if it gets bad enough, then we will start to notice wait time. But there's that middle ground where we're doing a lot of spinning, but we're not quite doing a lot of waiting. So how do we know if parsing is starting to become an issue, but it really hasn't kind of manifested itself yet into significant wait time? You can use this ratio here to tell you that. Don't use the ratio to say, well, because of this ratio, I need to make a change. No, use your time-based analysis to tell you where to focus your solutions, okay? But this tells us that, yes, there is some parsing. There has to be, because that's the top weight of it. But most of the CPU is not related to parsing. So is this a parsing problem situation? Probably not. Not yet. We need to see more. We need to get this into the 5 and in the 10%. When that starts to happen, then we will see more wait time and it'll say, aha, it is parsing, but not yet. Okay, which means this is probably just, okay, this is probably, oh, I heard somebody breathing here. All right. Somehow you guys can turn on your mic. I have to turn you off if you do that. Anyways, so probably this is just good old-fashioned high-consuming SQL statements. And so that's what we're going to focus on right now. Okay. So we could still find the SQL statements related to our cursor pin S. Okay. But we could also find SQL statements instead of when we're waiting, where it's CPU, and it would just look like this. Okay, you would just take this out like that. Okay, all right. So now here's how I do the SQL statements. Figure this out. Okay, I break this up. In fact, what I do is I go down to the SQL. Okay, we're almost done here, guys that are waiting. We go to the SQL statistics right here, and you notice how Oracle has these all kind of classified for us. So the question is, which one do I care about? What is the true top SQL? Okay, it's not a lapse time. Don't just say it's a lapse time, because what we have, if you look at all these, which of these is in short supply? Or which of these, if you look at our timing profile, okay, which of these is really the kind of SQL that we care about? It's not cursor pin S, okay? It may be a lapse time. We're going to get back to that. It's all about CPU. It's not about wait time, okay? It's not about reads. It could be about executions though, because we're dealing with parsing, but okay. It could possibly be, okay? But really the big one here is CPU. Okay? So what I do is, the other thing too is I will also include the operating system analysis, but it's not so useful now because I don't have a bottleneck on the OS. There's plenty of power. So CPU is where we want to focus. We want to find high CPU SQL statements. Now, this is so important, guys, because people say tune this SQL statement, tune that SQL statement, and if you ask why, they say, well, just because it showed up on my monitor. That's a bad answer, man. That is a bad answer. That's not a career-enhancing answer. You need to understand, well, why did it show up at the top of the monitor? And even if it did show up in the top of the monitor, how does that relate to our time-based analysis right here and what we're seeing at the operating system? Okay? Don't trust a monitor. You got to think. You got to think. Okay. I want to talk about elapsed time just for a second here, and we'll bring this together. Okay? We do care about elapsed time because we have plenty of CPU and we have plenty of I/O. So I would find long-running SQL statements and I will parallelize those, if possible. Okay, that's why if I had a CPU bottleneck, or I was really close, really pushing the I/O subsystem hard, I would say no, we don't want to increase parallelism because that's going to could slow things down. Okay, so let's find the SQL. There's our elapsed time SQL. There is the SQL statement, and there's the next couple right here. Okay, so usually I would write down the SQL IDs and all that kind of stuff, but I'm not going to do that now. So these are the SQL statements. Remember that BF7 and in fact, we better write that down. Okay, BF7 FAS FPN. Okay. Oh, that's the elapsed times one. Okay, so let's go down to CPU. Okay, and let's look at the let's look at the high CPU. FAS, there we got that one. FPN, that's that one. And FB7, there, boom, we hit it. We got all three of them. We got confirmation from both a CPU and elapsed time. So when we focus on these, on elapsed time, or when we focus on CPU reduction, we're also going to benefit from the elapsed time. And if these are truly like CPU per execution, like this 11-second one right here, that may benefit significantly from parallelization. Even this one with 6.5 seconds, that could benefit from parallelization. How do we know? You got to run it. That's how you know. Okay, so from an application perspective, we have some SQL statements to focus on. And we're focusing on the CPU intensive SQL statement because that is the big chunks of time and users care about time. Okay, I don't think it's a cursor pin S issue, mainly because the time's not that high and we're only using 3% of CPU. 3% of our CPU consumption is related to parsing right here. Okay. But there is some serialization issues. But what I really feel that the problem is here, and this really be confirmed by looking at the load profile here, okay, to see how logical I/O, see how that chart is. My guess is that this box is just not receiving enough work from the application server, from the web server. Okay, that would be my feeling for what I know, and that's how I would approach it when I talk to people. And I would get more information. I would tread lightly, saying that I don't think it's an Oracle issue. I think Oracle is just not giving it enough work. Give us more work. Give us more work. Now, the only thing that would really pull me from that is that if I saw one SQL statement that gets executed over and over and over and over again. Okay, in fact, let's look at that SQL statement, the high execution ones. Okay, executions, well, that's a big one right here. So we better check out the SQL rule, select rule bucket. We better check that one out. Okay. So this is the XG one. We need to see if that thing shows up a lot. Okay. Now it may be like runs. What's the only 9 total of 9 seconds? I don't know. So what you would do then? This is why you need to be able to use ASH. Okay, because you could say, you know what, this could be the SQL statement related to the cursor pin S. Okay, the only way you're going to know that is to do this kind of. Is to do these ASH statements right here. And that will tell you whether that's your cursor pin S statement. And even if it is the cursor pin S statement, if you look up here, if is it consuming a lot of CPU? It doesn't even show up here. So it's not consuming much CPU. So that may be the SQL statement related to the parsing, okay? But that doesn't do a whole heck of a lot here. And so I think we're good on our analysis. Wow. Okay. How you guys doing? Questions? Still there? No, you guys are still there. I can see you. Okay. All right. Just so you know, common mutex performance problems. Lots of similar but unique SQL statements. Okay. Too many child cursors. Okay. Both of the above, they increase memory management, searching, is the statement already in the library cache? And of course, we have to control access to the memory structures, and that all takes CPU. Not patched, okay? If there's a mutex issue, if you have a lot of time related, and you see cursor right here, you better make sure you're patched up on mutexes, okay? They're relatively new, okay? Relatively new. You could be out of CPU power, very common, so you could benefit from some additional CPU power in the short term. Okay, until you get things fixed up. I will always check to see if somebody messed with the instance parameters. There are like 3 to 6 instance parameters related to mutexes. They're all underscore. Just make sure nobody's changed those from the default. If they have, if they're still around, ask them why. Okay, and if they're not around, then I would say comment those out. Okay, that would be one thing to consider. So, okay. And I think that is going to be it. Yes, that's it. Okay, hey guys, this is the official end. If you have any questions, and I see some there, I'll take the time to answer that. I appreciate your time. We went over today. I tried never to do that, especially, but on the free public ones, I always want to get so much in, so sometimes I go over on that. Yeah, so thank you for listening, and all the best in your Oracle tuning work, and hope to see you guys again on one of the webinars. Okay, thanks for watching. All right, those of you that are going to hang on here, because usually we always get some really interesting questions. So, hey, thank you all for saying thanks. I really appreciate that. Okay, I spent a lot of time on this, and it's nice to know that somebody cares. Okay, all right. Question here. Okay, wow. Okay, we have almost filled up the room today at 50. I don't know if you guys, I don't think you guys can see that, but it was pretty busy today. Okay, let's see. Yeah, stat issue, cursor, huge light bulb, great. Got to leave. Looking forward to the recording. Yep. CPU time. Oh, okay. I got to grab here because it pops back up. Good. Yeah, stat issue. It could have been that updating, a lot of executions. I need to leave. Okay, great. Okay, question order by CPU. That's right. Hey, that is really key. We need to focus on on statements that are related to CPU consumption, because that's the big chunk of time, and then the executions, because that could relate to our wait event. Okay, let's see. Okay, what license do we need to use Ash? I'm not a legal guy, right? But I believe you need at least the diagnostic pack. Okay, just because you can query the view doesn't mean you can legally access it. And if you just do a select on it, Oracle knows. And if you get audited, they will ask you, what are you doing accessing Ash? That's the way it is. Okay. If you can run an AWR report, if you normally run AWR reports, then you have the diagnostic pack, I believe, and therefore you legally can run Ash. Okay, so yeah, that's a good way to do it. That's a good way to think about it. If you run an AWR report, that's no problem. Then you should be able to use Ash. But I'm not a legal guy, right? So, but I believe that's correct. Okay, let's see. Pressure to pin. Question. SQLNet from. Oh yeah, Parman, you asked about SQLNet from client. If it's one particular user, especially that's having issues, then that's when I really start to look at SQLNet message from client. Let's see, holiday in Brazil. Oh yeah, well that's way back. Yeah. Okay, do you have a rule of thumb for too many child cursors? No. That's really a tough one, because especially in 12G now we have the adaptive cursors with the feedback. When Oracle tries out a new execution plan, right, it will get a new child cursor. So you will have more child cursors in 12C. So that whole too many child cursor issue has not gone away. In fact, it's even more likely to happen now. But Oracle does put into place now in 12 and later versions of 11, there's a default underscore parameter. I forget what that is. That actually limits the number of child cursors to I think it's 1,024. And if you hit that, then the cursor will be invalidated, which means all the memory is deallocated or available for reuse. And the cursor is actually hard parsed again. And so you go through the cycle of hard parse, build up the number of child cursors, hard parse, build up the number of child. I mean, it's just crazy, But that's what can actually happen, and you can monitor that by looking at the number of of child cursors for SQL statements. Okay, let's see. Gosh darn it! All right. I think that is number of waits. I still got a bunch of you out there. All right. Let's see questions. Oh, do you think cursor sharing equals force could help? Excellent question, and I didn't talk about that. It could help if we have a lot of similar SQL statements. Okay, it's really easy to tell if that's your situation. Okay, by looking at the force matching signature and the number of SQL IDs, like per force matching signature. I'm working on a blog this week, and actually, I think this is the blog where I'm actually going to give you some real simple SQL to actually figure that out. In fact, I wonder if I even have that in my webinar notes here. No, I don't. I don't have the SQL in that for that. No. But that's all. But before you can do that, you need to make sure that's really the problem before you try force, though. Okay. Do you have any content on the process of a hard parse or a soft parse? No. But in Ash, there's a column called in hard parse. And you can use that in Ash. You can actually figure out, that's actually an upcoming blog because I'm doing some work on how to do this without an AWI report, just using Ash. But I think there is, let me do a search here. Hard parse, good, only 6 matches right here. Hard parse, DTM. Okay, hard parse SQL, I don't want that. I'm looking for hard parse CPU time. No, that's the mismatch time. Hard parse elapsed time. But that's just, no, not good. I thought there was a hard parse CPU time. No, there's not. Okay, so, but there is in Ash though, there's a column called like in parse. It's a yes or no kind of column. So you can actually do some math, some sampling, stats on that, and you can figure that out. Okay, that's what I would do in that. Because I think, is there something up here, hard parse? Yeah. Hard parses, that's like hard parses per second. Okay, what you could do, you could, because this is coming from $systats right here, what you could do is you could graph the hard parse right here. You could graph the statistic right here. And if you saw that go boom when users are screaming and then it goes down when they're not screaming, that's your clue that there is a hard parsing issue. Okay, but you should also see this percent of non-parse CPU. That should dramatic. If you're doing a lot of hard parsing, this number should dramatically drop. All right, I mean, it should at least get to the 80s or something like that. Okay. Let's see. Okay, so it's a combination of SQL order by CPU and elapsed time. I think it's primarily, I mean, it's CPU consumption, but it could be, those SQL statements that were consuming the CPU. I think that was really the issue in this particular case. Yeah, that's where I would focus initially, for sure. Okay, so I'd want to tune that SQL and run them less often. I should have said that. Dang it. Yeah, to solve. Focus on those SQL statements. Okay, that's really the main issue here. I don't know of anything I can tweak in Oracle. We don't need more OS power. Focus on those SQL statements. Dang, I didn't say that, did I? Sorry about that. So maybe people are watching their recording. Oh, thank you, Dan. Okay, any other questions? I've still got a bunch of you out there. Any more questions? We're going to all hang on here for like, 30 seconds to make sure there's no other questions. All right, so I think we're good. Hey, thank you for all the thank yous and compliments. I really appreciate that. Okay, I think we're going to close up. Thank you. Winnie, thank you. TJ and Dirk. How can I rewatch this? Man, that's a good question. That's the question, right? You go to my website and you go to training webinars. I put both the members only and the public ones on the same page right now. And you say there's the how-to webinars, and you will see it says new webinar coming your way. In a couple hours, it's going to look something like this, and you click and you watch. Okay. Now I'm a member here, right? So that's why you see these member only ones. You can see that I can watch them. Okay. But that's how you do it. Really, really simple to do. Okay. All right. Thank you, guys. All right. Hey, I'm gonna cut it off now. It's been almost an hour and a half. Some of you guys have been here almost 2 hours because you got on really early. So, hey, all the best to you guys. Have a fantastic week, and all the best in your Oracle performance tuning endeavors. Bye for now. All right, I'm going to shut down now. Thank you, guys. Really appreciate you watching. Okay.